Tenisha, Roos, using elephant behaviour as a welfare assessment tool.
Good morning, everyone. My name is Tenisha, and today I'm representing the Elephant Reintegration Trust. And I will talk about using elephant behavior and stress levels as a welfare assessment tool. Sorry. This presentation will only focus on a small section of the broader study. South Africa has many fenced reserves with various sized elephant populations, most of which have been introduced from either Kruger National Park or other private or smaller state reserves. In the South African context, management interventions need to be considered to ensure that a reserve's elephant management plan adhere to the norms and standards of management of elephants in South Africa. Elephants in fenced reserves may therefore be exposed to socially incomplete groups, translocation, darting, research, high tourism impact, contraception programs, and disruption due to constant infrastructure maintenance. These interventions and practices may impact the welfare of elephants. As my colleague Tammy explained in her presentation, welfare is a state which varies over a continuum ranging from poor welfare to good welfare. A prolonged or frequent perception of stressors have been postulated to indicate poor welfare. It is suggested that stress becomes distress when it incurs a biological cost so large that the animal needs to diverge biological resources away from normal biological functions. As seen on the slide, there are various long-term factors that can be used as indicators of poor or good welfare, such as looking at use of range, social competence, health, and behavior. Poor welfare may lead to serious consequences, such as increased interspecies and conspecific aggression, which could result in fatalities. Destructive behavior towards infrastructure, such as breaking fences, can also start to occur, which have cost repercussions. Reserves with poor game drive ethics may experience more charging events, and in some cases, it can result in damage to vehicles and also pose a threat to tourists. Animal welfare have been addressed from various angles, such as studying individuals' emotions, physiological changes, neural activity, and behavior, specifically in captive and domesticated animals. Assessing welfare of free-ranging elephants is still in its infancy, with little research published to date, which mainly focuses on stress hormones or ethics. Therefore, the aim of the broader study was to create a tool that in the long run can help us determine which factors and to what extent they influence elephant behavior and their stress levels. The tool could help reserve managers, government officials, and scientists to improve the welfare of different elephant populations and thereby preempt and alleviate any potential problems. However, before such a tool can be created, we needed to assess which parameters would be suitable to determine the welfare of a reserve's elephant population. The objective of the study was to determine which behaviors could be used to indicate nervousness and quantifying the fecal glucocorticoid metabolite concentrations in elephant groups as a biomarker of physiological stress. The study included 8 game reserves situated in South Africa. The reference reserve for this study, Reserve 2, has a size of approximately 140,000 hectares and forms part of the Greater Kruger National Park. The selected reserves also represent the current South African elephant population dynamics on fenced reserves. These populations can either be socially complete or incomplete and consist of either wild and/or reintegrated elephants and be exposed to different management intensities and tourist densities. Data were collected over a period of 2 years. An observation period of 6 weeks was allocated to each of the game reserves. Data collection consists of behavior observations as well as fecal samples. Prior to the sample collection period, we set up targets for various age and sex combinations to ensure that we collected samples that were representative of the entire reserve. A total of 490 fecal samples were collected and processed at the Endocrine Research Laboratory, University of Pretoria. A total of 368 focal observations were processed. For each reserve, we collected 46 10-minute continuous focal observations. An ethogram was compiled based on literature and experience and consulted to record detailed behavioral frequencies that were then grouped into various behavioral categories. The broader study focused on 4 behavioral categories: arousal, assessing, frustrated, and ambivalent behavior. However, today I will only be discussing a few detailed behaviors within the ambivalent behavioral category. Ambivalent behaviors are those that seem inappropriate or irrelevant, often displayed when an elephant is unsure of what action to take. A dual category, ambivalent or body care, was created for behaviors that were difficult to contextualize. Excel Stats and RStudio was used to analyze the data. We investigated various factors such as age, sex, season, reserve size, history, and social structure of the elephants using generalized linear mixed models. However, today I will only be focusing on how behavioral frequencies and stress levels differed between the different reserves. As seen in Figure 1A, the elephants on Reserve 5 showed significantly higher frequencies of ambivalent behavior when compared to elephants on Reserve 7. No significant differences were reported for the frequencies of the ambivalent and body care behavior shown by the elephants. Significantly higher frequencies were observed for the biting own trunk behavior for elephants on Reserve 5 in comparison to those on 3 other reserves. Elephants on Reserve 5 also showed significantly higher frequencies of the trunk twist twirl behavior than those on Reserve 7, a behavior known by zoo elephants. These graphs, as well as the graphs on the previous slide, show a general trend of higher behavioral frequencies for the elephants on Reserve 5. This reserve holds the largest proportion of formerly captive elephants. Reserve 5 is medium-sized with a relatively low tourist density. This may indicate that the history of the elephant might have played a role in the elephant's behavior. It is evident that not all elephant populations on the various reserves show ambivalence in the same way. Some show high frequencies of a couple of behaviors, and some ambivalent behaviors are even absent in certain elephant populations. Individual differences may lead to populations responding differently to various stimuli. And as a result of fenced reserves, elephants may have learned only specific behaviors, possibly resulting in different cultures. Traditional behavioral studies have focused on key, well-understood behaviors when investigating elephant welfare. If we looked at these traditionally defined ambivalent behaviors, we could have missed important signals. For example, Reserve 3's elephants show low or no frequencies of the front foot swing, biting trunk, and trunk and own mouth behaviors. However, they did show the trunk twist twirl behavior often. As seen above, no significant differences occurred between the frequencies of the detailed behaviors that fell into the ambivalent or body care behavioral category. As seen in Figure 3A and B, Reserves 1, 2, and 3 showed high frequency of the brushing face behavior and low frequency of the swing trunk through leg or to foot behavior. Again, these graphs confirm that all these detailed behaviors need to be investigated when looking at the welfare of elephants. When examining reserve-related alterations in stress levels, elephant cows from Reserve 2 had significantly lower levels than those on 5 other reserves, and the bulls had lower levels than 2 other reserves. It is interesting to note that the elephants on Reserve 2 showed relatively high frequencies of some behaviors. For example, they showed relatively high frequencies of ambivalent behavior, trunk and own mouth, as well as the touching and brushing face behavior. However, the fecal results showed that these elephants are not physically stressed. The higher behavioral frequency might have been caused by factors such as high tourist density, which include game drives and self-drives. It is also possible that the social relationship they have with other elephants on the reserve might have caused these higher frequencies. These graphs also emphasize the importance of including both behavioral data as well as stress levels to evaluate elephant welfare. The bulls from Reserve 5 had significantly higher stress levels than those from 4 other reserves. The females from Reserve 5 also showed significantly higher concentrations than elephants on 2 other reserves. This correlates with the behavioral results. However, it should be mentioned that these hormone metabolite values are within the previously determined range of male and female elephants. This study was the first step in defining behavioral and physiological parameters that can be used to ultimately develop a tool to assess welfare of free-roaming elephants. There were significant differences detected in the behavior as well as in the stress levels of reserves. The bottom line is, these results showed that these parameters can be used to assess welfare of elephants on fenced reserves. Further research is crucial. Therefore, our team is currently investigating which management and tourism interventions and other factors affect to managers, scientists, and policymakers. We greatly appreciate the willingness of the 8 reserves to accommodate us during the data collection period. We would also like to thank the EMS Foundation sincerely for funding this entire project, as well as enabling us to present our research at this conference today. Without their support, we would not have been able to complete this research.
Thanks very much. Questions? Pete?
Thanks for a great talk. I'm very curious to know whether there have been any assessments of the impacts of poaching on elephants. For instance, numbers of snares found on elephants' feet, trunks, and so on, plus encounters with poachers. So is there any relationship or any investigation looking at stress levels in relation to human incursions and damage?
So that is, thank you for your question. That's a very nice comment. Unfortunately, we haven't included that in our study yet, but yeah, it's definitely something we need to look at and would be very interesting to also add as a variable. Yeah.
No more? Thanks very much. Great.